Glass, the perfect combination of sand, gypsum, soda ash, limestone, and dolomite. A product once described as a rigid, uncrystallized liquid. A product reflective of the times and needs of its makers. A product known as glass. PPG's float glass plant at Meadville, Pennsylvania started its operation in 1968. The plant covers an area of 630,000 square feet, and every day, 7 days a week, produces 1 million square feet of glass. That's enough to equip 20,000 automobiles a day, 365 days a year. As in any glass manufacturing plant, the process starts here, in the batch house. Every day, raw materials are brought into the plant from all over the area by rail and by truck. Offloaded onto a conveyor, which transports them individually to their respective storage silos. The actual batching process begins when each material is transferred from its silo, weighed, and conveyed to the charging end of one of the plant's 2 melting furnaces. A glass melting furnace is a large brick structure, much like an old-fashioned baking oven, where batch materials and cullet, crushed glass, are melted to form liquid glass. Sand, which is by far the major ingredient in glass, normally doesn't melt until its temperature reaches 3,000 degrees Fahrenheit. However, when it's combined with the other ingredients in the batch, sand melts at temperatures below 3,000 degrees Fahrenheit. As the batch materials enter the furnace, preheated air is forced into the chamber by large fans. The preheated air combines with jet streams of natural gas to produce torch-like flames that spew out across the batch, causing it to melt in a matter of minutes. After the batch is completely melted, the fining process begins. This process allows the bubbles that form during the melting process to rise to the surface of the glass and escape into the furnace's atmosphere. Once the fining process is complete, the glass travels into the tank's forming chamber and through an opening called a canal, and into the forming operation known as the bath. This process is based on the fact that liquid glass floats, even as it is hardening on a bath of liquid tin. The spread direction of the glass is controlled by special refractories, which force it to flow downstream toward the other end of the bath. Toothed wheels, called stretch machines, are used to further alter the glass ribbon's thickness and width. Heating elements located above the stretch machines also control the thickness of the glass as it moves along its path into the narrow portion of the bath known as the shoulder. Here, the glass reaches its final width and thickness, ready to be cooled down by a series of water coolers and safely lifted from its tin bath onto the main line's conveyor. When the glass first comes out of the bath and moves into the Lear, it has been cooled down to about 1,000 degrees Fahrenheit. The Lear's job is to further cool down the glass at a controlled rate in order to ensure that proper stresses are put into the glass to make it cut well. After cooling, the glass comes out of the Lear at about 350 degrees Fahrenheit and is further cooled down by large open-air fans at 200 degrees Fahrenheit. As the glass moves through this cooling down area, it becomes more rigid and is carefully inspected prior to the cutting operation. Glass is cut by scoring it with carbide cutting wheels and snapping it over a roller which acts as a fulcrum. Meadville's mainline scoring equipment consists of slit cutters which score the ribbon in the direction of the flow and cross cutters which score it across the flow. After scoring, the glass, still in a continuous ribbon, comes to the mainline snap rolls where the cross cutter scores are open. From here, the plates of glass are routed down the main line, either one plate at a time or in small groups, to one of several packing lines. Approximately 90% of the glass produced at PPG's Meadville plant is packed at one of several automatic packing lines. The glass is transferred from the mainline conveyors to the automatic packing lines by means of a corner table, a belt conveyor, and roll conveyor all in one. The glass leaves the corner table and enters the snapping conveyors, where the slit cutter scores are opened. After the snap section has been cleared, the glass is conveyed to another corner table, where it's transferred, one row at a time, onto a series of narrow conveyors. Here, an attendant visually inspects each piece of glass for surface or edge flaws and drops the rejected glass into the plant's cullet system. Next, the glass passes under a machine which drops a special powder on its surface to provide a separation medium between each piece of glass. Finally, the glass is conveyed onto the automatic packer by a VTM system, a vacuum transfer module, which operates like a vacuum cleaner, sucking the individual lights of glass off the mainline conveyor onto the finished stack. As the stack gets higher, an elevator table indexes down to maintain a consistent drop of glass. Once the stack is complete, the elevator table is lowered and the finished container is moved aside, while an empty container is moved under the packing module. Following a final visual inspection for surface and edge defects, the container is sealed and moved off to shipping and out the door to one of many PPG customers. Customers which serve the automotive and architectural glass industries around the world. Customers who buy PPG glass day in and day out because it's the best.